All right, good morning everybody. Welcome to this next lecture in the stunning Epics training series. This is more of a demo, and if anybody's brought a laptop and actually needs help building Epics, then we can give you some tutorial stuff at the end. But mainly this is just going through the steps you need to do to build Epics base, modules, extensions, and also Synapse. I'm going to be spending most of my time on this system here, which is one of our regular Red Hat Enterprise Linux 6.6 machines, and basically demonstrating stuff, going through things. So let's see. So basically, yeah, I'm going to be building base, and it's actually the very latest version of base, which isn't quite out yet. So we're building the release candidate for base 3.14.12.5, and I'll be doing that on Linux and VxWorks, and we can talk about the stuff for other architectures should anybody have questions or need to do those kinds of things. And we'll run a test on that. Remind me that I need to do the test in case I forget. And then I'll go through and build some extensions. One extension which is used by some of the other build modules is called MSI, and MEDM and Strip Tool, our sort of main motif client tools. And then we'll go through and build a couple of support modules, one-off support modules, so the sequencer, which is obviously a very important piece of software, and asyn, which is sort of representative of some of the larger modules. But then usually when most of, certainly the Beamline guys, use this kind of stuff, you tend to do it as part of Synapse, and Synapse you can basically download a whole load of the software and build it all at once. And you know that those particular versions are supposed to interoperate. So hopefully we're going to build Synapse 5.8, and Tim will take us through that. And then he's also said he will show how to go about building XXX, which is part of Synapse, as a separate application module, so that you can build your own application with just the parts that you actually want in there. So let's get started on that with building base. So as I said, I'm actually going to be building 3.14.12.5 release candidate 1. The final release is due out next Monday. And a lot of these things, links here and so on, are for reference for people watching the video later. But here's the website for the actual base stuff itself. So you go there and you can find out some information, more documentation and so on is available from the regular link. Here is the download link for the particular tar file that we're going to be going through here. So I'm going to basically save this file, and it's done it very rapidly and put it somewhere. Where's it put it? Show all downloads. There we go, it's in my downloads directory. So let's go over here and put it in my home directory. Okay, good. So we have base. What I'm actually going to do is create a directory where we'll build all this, just so that it's not straight in the home directory. So let's put things into Epics, and we will extract the contents of that tar file. And here we have, this is nice and fast. All right, now when you've got the tar file, the first thing you need to do is edit the configuration, make sure it's going to do what you want. And actually before that, let's have a look in this startup directory. The startup directory contains a series of scripts which you can use to set the Epics host architecture variable, which is for your specific platform. If I run one of those, there's actually, so Epics host arch is a shell script, Epics host arch.perl is a Perl script. They both return the same thing. So let's just run that, and it tells me Linux x86_64. So it's a 64-bit Intel processor that we're running this thing on. Actually, normally I would need to export Epics host arch equals, and that string, but I can do it by running that script inside back quotes. But in this case, actually, the machine already has this. So it's already set, so I don't need to do that. Now let's go into the configure directory. The config directory is an old one from older versions of base, so generally you should never need to touch that. And nowadays, nothing uses that config directory anymore. Inside configure, there's a whole load of stuff. The things that the way that we've designed the build system, things that you need to edit are almost always config site files. They say config site. Anything else you generally should never need to edit at all. So if we actually look at the config site file, it contains a whole load of stuff about, okay, so that tells us what the architectures are, and this says EPICS host arch is a required environment variable, so we already set that environment variable. And it suggests we can use the base startup files to do that. And then it also has cross-compilation. We're not going to build cross-compiles quite yet. We'll come back to that. When we do, we'll need to set this variable to tell it which architectures we actually want to cross-build for. And if you're doing cross-compilations but you have multiple host architectures using the same installation but only some of them do the cross-build, you might need to set that variable, but in general, you don't need to. Most of these settings you probably want to keep as is. There are times when you might, certainly if you're building on Windows, you may need to switch. You may want to change to set shared libraries equals no and static build equals yes. But in general, on Linux stuff and Unix workstations, we use shared libraries, and so we build like that. All these things generally are internal and probably don't need to be changed. We're not bothering with. If we want to say, if you're installing it in your particular site, and you want to say this actually is a specific, I have some site configuration or some site modifications even. You may have patches that you've applied to base, and you want to actually have your own version string as part of the EPICS version number that gets displayed when you show when you run the IOC or look at the EPICS version string. You can add that string to here. It will be a short string, but this is a place where you can actually do that. These things are generally for specialized builds. So EPICS site version is generally the only other one that you would change in here other than the cross-compiler target arcs. So that's the config site file. Now there's also an OS subdirectory, and it itself contains a whole load of other files, including lots of config site files. And those allow you to set specific configuration for particular architectures. Again, you only need to modify the config site files, so ignore all the others, but here we go, config site. And so the naming here is the middle name. This is if you have a specific build host, is the middle part of the name. The final part of the name is for the final target architecture. So if I wanted configurations, if I was cross-building stuff for RTEMs, and I wanted to put some settings that were specific to RTEMs, then I would put those probably in this file, or if it was for a specific target under RTEMs, they might go in a specific in this file here, or one of the other files. I might have to create files. They don't all necessarily exist. Common VxWorks common we'll come back to later. The other ones here then have the host architecture as well as a target architecture, and these allow you to say, okay, when I'm cross-building for this particular target on this particular host, these are the settings that I'm going to have there. Again, so a lot of these files don't actually have anything in them, but you can also use these files for setting your cross-compiler target arcs directories. For now, for the straight Linux x86-64 build that we're doing, we don't need to modify those at all, so we'll go back to the top of base. And So we just have the source directory, and the nice easy stuff here is we just type make. Now, that's going to go away and do a lot of building stuff. And while that's doing that, let's come back here. I did say prerequisites here, so there are some prerequisites before you can actually build base. Most of these you won't need to worry about if you're on a standard Linux installation, because they tend to get installed by default, or there may be a single package that installs them all. I think on Ubuntu they call it build requisites or something like that. There's a package that basically contains all the compilers and GNU-make and so on. But if you're building on Windows, then you'll usually need to download stuff and install things to make the build actually succeed. So the main prerequisites for base are GNU-make. It has to be the GNU version of make, although nowadays it's pretty much the only one that gets used. Some version of Perl from about 5.8 onwards. Nowadays we're up to about 5.20, so any recent version of Perl is fine. And you need compilers and related tools for C and C++. Normally that's going to be GCC on Linux. This does actually build for Clang. You may need to modify the configuration file slightly to tell it that it's building on Clang, but it does work with Clang as well. On Darwin, certainly it uses Clang by default on Mac OS. So those are the main things. If you're for running IOCs in general, you would like to have command line editing and command line recall. And the command line history is done by this GNU readline package. Normally on a Linux box, GNU readline is installed as a library, but you don't have the developer, the header files that you need to actually compile something to use it. And so usually people, if you're seeing questions about that, you have to install a package that basically contains the readline header files. So if you're on a Red Hat type or a Fedora type system, then that's an RPM called readline devel. On a Debian Ubuntu type system, then that's libreadline-dev. So those are the prerequisites that you generally have to have installed to build base. I didn't show about configuring that. Okay, and while we were talking about that, base has finished building, and everything's installed, and we've got an OK. So we now have a fully built system. That was nice and easy. Lots of stuff here. We can't go back through all the history, but basically you can see that there's a few warnings, but mostly it's a clean build. And we don't worry about those particular warnings. We've known about those for years and have been clearing up warnings as we go over the recent years. So this is a copy of base. I can actually run up an IOC. There's this soft IOC, and I can start that, and that shows that the thing is working. And the -X, A, and J basically says create an exit record. It loads a special internal database which creates an exit record, which when processed exits the IOC. But that's just a useful little test to show that the IOC is building and working. So we close that down, and now let's go and test our build. So I'm going to run this script called make-base-app, and make-base-app allows me to create an example application, and these are the different kinds of example applications we've got. And what I'm going to do is I'm going to go a type example, and I'm going to call it test. And so that's created me a test app, and I'm going to run that again. But I'm going to add it a -I option to say I want to build an IOC. And I'm going to call that IOC first. And I want my application name here to be test, since that's what I gave previously. And now I have an IOC boot IOC first, which should boot the test app. So now I can run that, or build that rather. And let's make the startup script executable and just look and see what's in it. It's going to run my test application and load all the standard example things. I don't have a sequencer, so I don't want to start that. So now I should just be able to do that, and we start that IOC. Okay. And on that IOC, I have all my usual example records. So there's my AI1 record. And the value is changing. It went from 0 to 6. Okay. Now we're done with that. So we have a working builder base, and we managed to build an IOC, an example application using it. All right. Any questions on building base at that point? Okay, let's now look at cross-compilation. So what I'm editing now is the file. I said we're going to build cross-build for VxWorks. So I'm editing this config site common VxWorks common file. And this is the one that says which version. It basically tells it how to find the VxWorks cross-compilers. And it tells it which version of VxWorks we want to use. So let's make a change on that. Let's build this against VxWorks 6.9. And where is VxWorks 6.9? It's not found there. We have to now point it to that. It's actually found here. With VxWorks version equals 6.9, then that's actually where we can find the VxWorks installation on this machine. For VxWorks 6.x, we have Workbench 3.3, and we have Utilities 1.0. So that's the configuration on those. Now, there are actually a number of different VxWorks configuration files, but we don't need to modify them. We could look at that one, for instance. Sorry. As you see, it's empty because we don't actually, but we could put things into those other files if we needed to. The other thing that we have to do, oh yes, we do actually have to edit something. I have to edit my config site Linux x86 64 common file, because here I need to actually tell it which VxWorks architecture I want to build for. And in this case, I'm actually going to add a new one here. VxWorks-PPC32, which is the standard VxWorks target for most of our VME PowerPC CPUs on VxWorks 6. Oh, thank you. Second pair of hands is often helpful. Cross-compiler target arcs. There we go. Okay, now we can go up to the top. And now, if I run make again, it's going to go through and it's going to try building the Linux stuff that it's already built for. But it's going to find that it doesn't actually need to rebuild most of that. But it will then build the VxWorks stuff as well. So now it's going through, oh, I can't do that because I don't actually have permission to build VxWorks 6.9. So I'm going to have to change that back to VxWorks 5.5 because the VxWorks 6 stuff is user limited, and the account that I'm running on isn't a member of the group to allow access to it. So I need to change that. Sorry. So we will go back to where we were, which is that one. I don't need that, and I don't need that. And then I also have to switch from x86-64. I can't do that one. I have to go back to, actually, PPC 603. No, it still doesn't like. Oh, it's trying to do something. I missed something. I forgot to change the VxWorks version, didn't I? There we go. All right. That's better. Any questions while this is doing its business?
Going back to the EPICS configure OS directories, there's like 6 different patterns to that. I know it's rather confusing, and only one of them I know of is mandatory. That's the config epicsarchitecture.com.
So the question really is about the contents of the files in the configure OS directory, and yes, which files are required for a particular target architecture, and so on. And yes, in general, if you're creating if you're naming a new target architecture, which is really a copy of another one, which mostly we are in those circumstances, because you may need to build for 2 different versions of VxWorks or something like that. Then yes, the actual set of files that you need is limited, and yes, I think only one of those files is strictly required, although some of the others you may need. The naming, as to exactly which they are.
Well, my real question is, I think there was some plan. You did plan on making some revisions to that. That's still in the works. For the foreseeable future, that's not going to change.
Currently, we don't have anything particular that's changing the set of files and the requirements there. We may. I did do some development a while back about what I called architectural or hierarchical architecture building stuff. But I haven't got completely through with that, and I sort of haven't worked on that for a while now. And that wouldn't necessarily change exactly which files you need. It would make it easier maybe to basically for the system to work out which files this file is related to that one just by the name, and so it pulls things in automatically. It's a while since I worked on that, so I don't remember exactly all the details, and I don't think that's likely to come in. I don't know whether I'll ever merge that or not. I'll have to look back and see whether it's worthwhile, based on my experience with doing that. But that will be some time before that comes in. So yes, for the time being, then the files that you actually have to have if you're adding your own target architectures are going to be the same. Okay, so it looks like our cross build now succeeded. And so we compiled everything there. One thing that we can also do is we can go back to our example and let's see. We can try running make base app and tell it I want to create another IOC. And now it says, I actually have two target architectures. Which architecture do you want to use? So this one I'm going to make use the VxWorks architecture, but we'll still build the same test IOC. So now if we look in IOC boot, we have a second directory, IOCVX. And if I make here, then it compiles that stuff. Now, I haven't got a VxWorks IOC here to actually do the test for, but at least we know that we can build it. If we compare the directories of the VxWorks IOC with the host IOC after building, VxWorks IOC has this cd commands file. The host IOC has this env paths file, and I wonder why we don't have a README for VxWorks. Maybe we don't need it. What does that README say? Just gives some instructions on how to start the IOC. Okay. So now we have a working build and host build and cross build. So let's move on. More questions?
Yeah, so when you boot a VxWorks, you typically then boot it off of a network device that you've done the compilation on, or?
Yes, the way that almost all the VxWorks IOCs are run, certainly around here, is you download the operating system and the application off a network, off an FTP server. Well, initially off an FTP server, and then we usually mount NFS and load the rest of the files over NFS.
So is there ever cases, well, there's probably a case where you could cross-compile and then download it to another device, or put it on an SD card or something, and then boot off of that?
VxWorks has the ability to boot from files. So for VxWorks, you can from disks. So you can have local disks and so on. So you can do that kind of thing. Currently, EPICS will not build to allow you to program it into ROM, like you have to program the boot ROM on these VME systems. We don't actually have the ability to blow the whole application into a ROM yet, because we require a file system to actually get to the database files and so on. But the RTEMS builds, the RTEMS target that we have, certainly here at the accelerator. There are a lot of small RTEMS IOCs where they do actually program the whole of that application into ROM, and that all then gets loaded locally from the system. Nick, does that still use NFS to get hold of files?
Yeah, afterwards it starts off FTP, and then I think it does switch over to NFS.
Right, so you are using NFS to get the database files, but the application itself is blown into the ROM.
Right, I burn it into the ROM.
Right, so for RTEMS we do actually have that stuff built in. It's probably possible if somebody really wanted to do the same thing for VxWorks to burn that into ROM, but probably better to do if you have a local compact flash disk or something like that, to use something like that, just so that you have the ability to change out the disk, to update the software much more easily. Does that answer the question?
I think so.
Okay, thank you. Any more questions on this before we move on? Okay, then the next thing then I said I was going to do is work on extensions. So extensions is the way that we built extensions for a long time. Is the sources for the extensions don't contain the full build configuration files. We actually provide those as a separate tar file. So this thing here, this extensions top that I'm downloading here, this actually contains some of the stuff necessary to build some of these other later extensions that we'll come on to. So I can't just download this MSI tar file and expect it to build. It won't work. I first have to download and install this extensions top. So we will save extensions top and have a look and see what we have here. So this actually creates an extensions in a configure directory and so on files in there. So I can tar extract that. And now I have an extensions directory. And if we actually look in source, there's nothing in there but a makefile. But we do have a configure directory. So let's go in and look at our configure directory. And this also has a release file. Now, I didn't show the release file in base because it's empty. But this one, we do actually need to edit the release file. The release file is what tells the build system where to find all the other components that it's depending upon. So in this case, EPICS base by default is set to top, the parent above the extensions top, and base. And here I think I need to add, can anybody remember exactly what the path was? R3, 14, 12, 5, RC1 maybe. I probably didn't have the R in here. Let's check that in a moment. And we don't actually have OAG apps. We don't need those anyway, so let's comment that out. Base 3, 14, 12, 5, RC1. Okay, so I got that right. Now, again, we have an OS directory, and there's config site files in here. And let's look at, nope, there's only one common, so let's look at Linux x86 64. And see what we have in here. So this sets where we think the standard locations are for things like X11 lib, OpenMotif, other things. Most of these we don't have and we won't want. These are configurations for MEDM, which we will get back to. I think I can leave these alone for the moment, and we'll just try them as they are. If you're using a different operating system, different distribution than Red Hat, then you may need to change some of those to actually point to the relevant locations to where the libraries and include files are found for those. But for now, let's look in here. So source contains nothing. All right, we need to go and find an extension to build. And I said we're going to start by building MSI. So we will save that MSI file. Let's have a quick look at and that comes under MSI 1.6, so we can just untar that. Right, here we are, and here is that MSI. And this is actually a really simple application. There's only one C file, and we should just be able to run make to build it. And there we go, it built. So now that we have that MSI, and we can ask for help, and it will tell us what its usage is. We'll come back to actually needing this for the moment. One thing that I will do, because I'm going to need it later, is set my path. Actually, there's already a copy of MSI in my path because it's actually found in this user local epics extensions bin directory, which was already in my search path. So I don't actually need to put this extensions in my path, but I think I'm going to change that. And take out that and put bin/Linux x86-64 in there instead. Okay. So now if I go which MSI, I find it's still finding it. Why is it still finding it? Okay, I missed something. There seem to be 2 copies of extensions in here. So we'll take that one out. And now we find our own epics extensions bin. So now I can run MSI-V, and it's working on that one. All right, so that was our MSI extension, which is, as I said, very easy, and that's installed it in the bin directory. Let's go back into source. Was there anything else? Okay, so MSI required us, prerequisites was basically to have installed this extensions configure. So that was all we needed for that. Now it gets a little bit more complicated, but in fact, it doesn't, because the build, everything should be set up already. So we will need the same issue, but we're going to now try installing MEDM, and for some reason this is not a link, so I can't click it. But what I can do is I can come over here and let's open a new tab on my terminal. No. Copy. There we go. Okay, so now we have MEDM. Let's go back to the other tab and extract MEDM, and that is happening really nice and fast. Now in this case, I don't know whether this is going to succeed because I haven't tried this in advance, but let's see whether MEDM builds. It looks like it's going to, because, as I said, we happen to be on the same Linux distribution here as we develop MEDM on. So all the configuration settings were set properly anyway. There are a few warnings, but it builds okay. So let's see if we can run MEDM. Bingo. And I can create a screen, and of course I don't have a 2-button mouse here, so it gets a little complicated in terms of no. Okay, so I can't actually edit this because I don't happen to have a 2-button mouse, and you need to use the right mouse button to do that. But anyway, no, it's okay. We don't actually need it.
Well, I'm not going to use it.
Well, then you might want to go and get hold of a mouse then. Okay. Okay. So MEDM, and that built nicely now, and that was if we look and see some of the things that it was doing here. So it's actually getting include files from our EPICS base, and so on. And then when it does the link stage here, it's linking to, searching for libraries in our build of base and so on. So we know it's using the code that we've just built. Any questions on this at this point? Okay, so I didn't cover prerequisites yet. MEDM has a lot more prerequisites, and so if you're building this for yourself, then you will need to get hold of things like the developer packages for OpenMotif and various other Xlib libraries. I think this Debian list is accurate for things like Ubuntu. So for Debian type things, then this is the list of packages that you actually need. I'm less sure about this list for the RPM stuff here because I don't have to install them because it's already all installed by the IT guys. So this list of RPMs may not be complete, but this list here is available on the MEDM web page. So if we were to go to this web page, it would actually shows us that list. Any questions on building MEDM? One?
Yeah. I don't know if you'll know this, but with MEDM, the source code for the Windows paths refer to Hummingbird exceed the Xlib libraries, which seems to be the easiest way to build it. But there's the EPICS Windows tools, which has a pre-built version of MEDM. Does that use the Hummingbird exceed libraries? And if so, is there a legal issue with using
No,
commercial libraries built into MEDM?
That uses the Hummingbird exceed, and we've paid the license fees. You know, if you buy Hummingbird, and you are allowed, it has redistributable libraries in it. So we include the libraries that you need, and that is fully legal.
Okay.
So yeah, there's no question, no problem about that in the distribution, and it even includes some of the Windows libraries and so on that it relies on as well. So all those things in the EPICS tools. I mean, if you're running on Windows, that Windows tools extensions, if you're using these tools, that download that package and use that. Don't try and build it yourself. It's really not worth it if you can avoid it.
Has something that doesn't use the registry or files within the actual install directory, but the EXEs still need to know exactly where they are. They're not able to be moved after they're built or after they're installed. And
I think it does set up the registry. That it uses the Windows MS.
Two things in the registry, but I've modified them, and it still doesn't work when you move the EXEs. So I was trying to see if I could build it in order to make something that's movable.
Okay. The answer to that question is go and talk to Janet Anderson.
Yeah.
I mean, she manages that and builds all that, and she knows should be able to tell you exactly what it is that you would need to do and if it's possible to do what you want. But it may be that it's not possible to do. I'm not sure. But you know that we do actually have to have. I mean, I would have thought that the DLLs, as long as the binaries are in your path or in the same directory as the binary, it ought to. But I'm not a Windows expert, and I don't have Exceed on my Windows box anyway, so I've never tried doing that. So okay. Any more questions on MEDM? Strip tool is very similar to MEDM. It basically has the same sets of prerequisites, or maybe slightly fewer. But if you've built MEDM, then strip tool is really just a repeat of the same thing. So we'll just grab that and do the same thing. Ooh, it shows I haven't actually tried building this. And somebody did actually produce, there was a comment on Tech Talk recently about conflicting types for base name. I'm not going to try and debug that now, but we obviously have an issue currently with building strip tool on the latest version of EPICS base, so I need to go and talk to Janet, and I'm no doubt there'll be a new version of strip tool coming out soon that clears this one out. So yes, it has. Oh, previous type was user include string. Okay, so yes, that obviously needs fixing. So I can't build strip tool here, but luckily nothing else that we're going to do today requires it. So that was. So this version doesn't work with the latest version of base, which is good to know. I'm slightly surprised that Janet isn't aware of that, but anyway, we will work that one out. The other thing then, standalone IOC modules, modules containing code that IOCs actually need to run. So those extensions are clients that are running on the workstations. For other code that's actually going to run within the IOC, we don't build as part of extensions, we build separately. So the one thing that's most common on almost all IOCs, or a lot of IOCs, use the sequencer. So I'm actually going to download, I'm using version 2.1. There's a new series of sequencer versions called version 2.2, but I'm being conservative here and staying on the older version. The new stuff is pretty new and may not be as compatible with everything else that uses it. So for the time being, I'm just going to show sequencer 2.1.18, which is the latest version. So I click on that, and it will take a little while downloading that. But now I can save that. Just looking at the prerequisites here, EPICS base, but there's a prerequisite here called RE2C, RE2C, which is it's actually a program that takes in a series of regular expressions, Perl regular expressions or Unix regular expressions, and generates C code that matches those. And this is an external module that the sequencer relies on. It's available in most cases. Most distributions have a copy of RE2C. In this case, we have the RE2C binary installed already. So on this system, it's found in this RPM. So we have it available. I'm not going to go into extensions, so let's create ourselves a modules directory and go in there. And untar the sequencer. Now, we have to set our configure release file, and base equals, where was it? Home. Actually, no, it's not. Local user 0. Local user 00 / epics / base - 3 14 12 5 rc1. Okay, so that's that. Let's look at the config site file in case there's anything in there we need to deal with. Some stuff about internal building parts. We don't need anything other than the standard PVCA. We'll leave these things as all as their default, and we do have read-to-see available in our search path, but if it's not, then we can set that. It also has this internal program called Lemon, but that's using the internal one, so that's okay. So that should now build the sequencer. And notice that it is building some things using GCC and some things it built some stuff with the VxWorks compiler. So it actually has there's two parts. There's the compiler part, the state notation compiler, and there's also the runtime. So the runtime has to be built for the target and for the host, because the host is a target, but the compiler is only built for the host. So what we have now is, if we look in our bin directory, we have the all-important SNC compiler and these other things, examples and demos and tests and so on. There's a whole suite of tests that can be run in here if we wanted to do that, but I'm not going to worry about that. Now, we've just built the sequencer, so one thing that we can do is, let me make a copy of that path. And now go into my example. No, I want to edit the release file. And come down here and tell it where to find the sequencer. So now, by telling it where the sequencer is, if I run make, it's actually going to build some more things. It compiles some extra programs, both for the host, or some extra modules into the IOC, I guess. And we also want to go into our IOC and edit our startup script. And now we can enable this sequence program to start in the startup script. So if I now run the IOC, it runs the sequence program, and it said seek not found, probably because I might need to actually rebuild the IOC. So let's do a make rebuild instead, which will clean out all the old build and build it again, and now it should have the sequencer stuff into it. So all right, now we go. Now it's started the sequence program. Everything is connected, and I can show that my sequence program is running, and it's now going to start spewing out messages on the console. So that shows me that the sequence is running. So we were successful in building the sequencer. Any questions on that so far? Okay. The other module then that I have here is asyn, which is maybe somewhat larger. Prerequisites here, you only really need base, but if you have other modules, libUSB, it allows you to talk to certain test and measurement class USB devices. So asyn has support to talk to ADCs and so on that you can actually plug into your PC and actually access them that way. And IPAC, if you're using some of the industry pack 8-port serial modules or other industry pack modules, you can use those. I'm not going to worry about IPAC. libUSB should be installed on this machine, but I'm not going to specifically configure it. We'll see whether it gets built or not, if we can work out whether to recognize that. Okay, so let's save the asyn tar file. And go back into our modules. And extract asyn. Now, set the release file. I'm going to comment out this lot because I don't want any of those. We don't have IPAC. Comment that out. I will set. Oh, wrong one. Let's do. There's my sequencer. This is going to be base -3.14.12.5 RC1. And that should be all we need to set in there. And we can just run make, and asyn should build. Which is not quite as bad as watching paint dry, but asyn also has a whole load. So currently it's building test programs. There's a whole load of test IOCs and so on in here, so that the developers can check that the thing is working and test things. So that's asyn having built. Now I don't actually have any examples or any way of testing what we have here, but if we look in here, so we did actually build. No, it looks like our test USB TMC did not build, but I'm not too worried about that. I'm not sure exactly what needs to go on. It may be that we need to tell it. I think I need to tell it. The config site file tells it, yes, if we have libUSB, so it requires libUSB revision 16 or newer. So let's try setting that. And if we run make now, oh, it's not happy. It says you need to get a newer version of libUSB. So obviously the version that we have installed on this machine is not libUSB 1.016. It's something else. It's an older version. So that isn't going to build here. All right. Any more questions on IOC standalone modules? Basically, you have to go through and make sure that your release file is pointing to everything, all your dependencies, and then things should just build. And if they don't, then it may be a dependency issue, or it may be a version stuff. In general, these things do tend to just build once you've got the configuration right. So the release file and the config site file, you should check.
Okay, so I'm going to build Synapse 5.8 and show a little bit how to use the XXX module within Synapse 5.8 to create an IOC, a single IOC. I've already actually I haven't downloaded anything. In tar files, it hasn't been released yet, so I just have a copy of what's likely to be pretty close to Synapse 5.8. I think the only difference is 80 Core 2.2 is what we're waiting on. So I'll just go to the epics directory and untar that. What?
Just click, yeah, click the window.
No, it has never needed that in the past. Oh, I'm not. I made it work before. So it's pretty big. There's a lot of display files in there. That's most of what takes up the space in Synapse. So to build this, after you've already built base, building Synapse should be fairly straightforward because you've already worked out all the problems that have to be worked through in order to get the basic infrastructure to work. So what we need to go is go into the config directory. Let me just check and see where this. Okay, so can you guys in the back see that?
It's small.
It's small. Sorry. I don't know how to quickly to make this thing larger. Fortunately, we're not going to spend much time in this file. All I really have to do is tell this release file where we are, where Synapse is going to be. And that's going to be here. Oh, in support, where the support directory is. And I also have to choose a version of Epic Space. I already have a version that's built that I know that this stuff is going to be able to build against, so I'm going to just continue to use that. It should be essentially the same as the version that Andrew just built, except that this is built against VxWorks 6.9. And Synapse 5.8, I mean, most of it doesn't really care, but there are parts of it that really won't run correctly against VxWorks, against any earlier version of VxWorks. Okay, so now I'm in the Synapse support directory, and I've modified the top-level configure release file, but all the modules underneath it also need to be modified, and I don't have time to go through that. So Ron Sluter wrote a program that just takes the release information from the top level configure release and propagates it down into all of the release files in all of the modules that are in the support directory. And he's made that part of the build system. So you just do that. And if you don't see any errors, then that means that all of those files were writable, that everything that it was looking for actually existed, for example. So having done make release, all we have to do is is just run make. But there is a little bit of a problem because one of the modules in Synapse 5.8 doesn't build with parallel make. So what I do, I've made a little script. That it just goes into the sequencer, uses parallel make for that, goes into dev IOC stats, doesn't use parallel make for that because I haven't fixed that yet. And it goes back into the support and does parallel make for everything else. So. Oh. What? Oh, thank you. Because part of that stuff started to run even though it wasn't able to write into the file at first. I just decided to clean everything out. So I guess what I should do is get another terminal and we can look at that.
Actually, you can do it from the dump line. You open a file.
Oh, open tab?
Or at the dump.
Oh. Cool. All right. So then we can just look at what all is going on. It's not all that interesting. All I ever do really is look for 3 asterisks in a row in the file, and if I don't see that, then I assume that everything is okay. If there's warnings and stuff like that, I sort of feel like that's the developer's job to worry about that kind of stuff. And I mostly just worry about whether or not the build actually succeeded. This is going to be a really long file. So, anything people want to talk about while we're waiting for this? Yes.
I want to make a comment. There's a common misconception when you're doing a parallel build that if you get an error because it hasn't been configured correctly or all the dependencies haven't been done correctly, that you have to clear it out and start over again, and that's not true. Sometimes if you just run another make, those problems go away and you get a good build.
Yes, that's true. That is a good thing to point out, because the fact that parallel make fails doesn't mean that something didn't get built. And it might be that what did get built is what's needed for the next one to succeed. Yeah, that's a good point. So I forget, well, I don't know how long it takes on this machine. But normally you're just going to do this once, right? And at APS, what normally happens is this thing just builds on APS share, and it sits there, and then anybody can use those modules. And so most of the actual building that goes on to support beamlines is building of a copy of the XXX module, which I'll get into a little bit. Oh, it finished. So let me go ahead and look and see whether or not. I'm sorry? Yeah, I just want to search. And see whether the build actually succeeded. All right, so I don't find any stars, so I'm just going to assume that everything's fine and move on to the next part of this. Now, in principle, we could go into the XXX module and actually just run stuff. But XXX is never really run from here. Its purpose is to be a template for an IOC, for a single IOC directory. And so what we normally do on APS share is clean that thing out, but its release file is set up to build to be compatible with this version of Synapse, right? So I'll make a tar file. And then all right, so now I have a copy of XXX. And I'm just going to call that XXX. Or no, how about I call that YYY? And then, so the other thing that you need to do is, because all of the databases and the MEDM displays and some other code, in fact, in that module is identified with the prefix XXX colon. You know, you have to have a different prefix for every IOC that's on the same subnet, otherwise those names will collide. So the way this is handled in Synapse is with change prefix, but I don't think I've actually got that installed. Let's see where. So I'll copy change prefix to my bin directory, and I happen to know that that also relies on another program that's in utils. It's called doSed. What? Oh, thank you. That's great. Yeah. Yeah, I never thought about not having a bin directory. So this is my Phoebus account, which I haven't used since '97, I think. Oh, and there is a new version of change prefix that doesn't require doSed, right? Keenan wrote that, and that's a Perl script, right? And that's also in utils, right?
Yes. If you want to switch entirely over to that, I mean, I can keep up with it.
Yeah, I think we ought to do that, because change prefix requires that you have the shell, the Bourne shell, or bash, whichever. But yeah, we should switch over. But I haven't. I'm a stick in the mud. I haven't done that yet, right? So I'm going to go ahead and let's see if that's showed up there. Oh, I don't have bin in my path, yeah. Okay, good. So it's in there. So then doSet is also in there. So now, in the XXX, I can do change prefix. So from XXX to YYY. And it'll go through all the, mostly these are the things in the IOC boot directory, on the IOC directory, and also in the op ADL and op OPI and things like that, those directories. So I should simply be able to run. Oh, that's right, I have to build it. Oh, and before I do that, no, I don't have to change anything, yes. Okay. So I should actually show. So this is the IOC boot directory, and there are IOCs for Linux and for VxWorks, and there's one for Cygwin that I'm not actually sure how up to date it is. The Linux and VxWorks ones are run often. So. So I should just be able to run this thing. So I saw an error message scroll by there. It said it couldn't open the save file. Which is not really very surprising because there isn't one. But it just wrote it. The auto settings, let me make sure those things are actually current. Okay, so it just wrote auto settings and auto, so it's running. I guess I'm not sure what else, I guess we could try to run MEDM and look at this thing. Oh, there's another little bit of editing that we have to do. Set up EPICS common. We have to tell this IOC, or this IOC directory, we have to tell it where it is so that this script can be run from anywhere. Oh. Sorry, ed doesn't exist here. Oops. Typing, man, I really hate it. I just like clicking on stuff. Oh, my mistake. This file doesn't need anything. It just needs the caller to set everything up. So here, the setEnd EPICS app, that has to be the directory where this file is. So now we're done. We ought to be able to just run. Start epics YYY. And it comes up. Where did that thing go? So, I don't know. So the whole thing's live, and that's what it takes to build Synapse and to build one copy of the XXX module with its own prefix so that it can run independently of everything else. So what did I miss, you guys? Or any comments or any questions? Because I'm thinking that I'm pretty close to done. Actually, I think I don't have anything else to say unless you guys have stuff. Yes?
Why do we only have to, why do I only have to build XXX?
Why do you only have to build XXX? You can build as much as you want. A lot of people do, actually. A lot of Beamlines build their own copy of base and their own copy of all the Synapse stuff, and then take XXX and use that. And that does give you more flexibility. You can make changes in the target architectures, for example, if you do that. I only build XXX because it's just a lot easier. Because it's not going to be any different if I build Synapse from what is on APS Share, typically. Again, except there might be... Yeah, it's already built on APS Share, and Synapse is designed so that it can run from a read-only file system. Almost everything in it can be pulled from a read-only file system, which is the dservs, right? So all of the databases and all the MEDM displays can be pulled from that read-only file system, and then the only part that needs to be read-write is your copy of the XXX module that you have to be able to edit in order to personalize it, and also that has to be able to write autosave files, for example, or other kinds of files that the IOC is going to write. So I guess the answer to that is just that it's easier. And there's a bunch of them. We got hundreds, right, of these guys. So you kind of do want to just do the minimum amount that's necessary to fully support an IOC and arrange for that to be as easy a process as possible. We have hundreds of IOCs that the Beamline Controls Group, for example, maintains, and each one of those is essentially derived from some version of XXX. It could also be derived from Make Base App, but because XXX already knows about all the stuff that's in Synapse and knows how to build it, what order to put it in, and all that kind of thing, it's just an awful lot easier. You don't have to worry about those kinds of things. I'm sorry? The what? Oh, thank you. So if we find out, for example, that one of the versions of the modules in Synapse, let's say the autosave module, if we find, as I did actually, a serious problem in the autosave module in Synapse 5.7, then I can fix the problem, load a new version of that module, also in Synapse 5.7, and then anybody with an XXX module can edit their own release, and instead of pointing it at the default autosave module, they can point it at the fixed one. And then they rebuild, and then they get all of Synapse, but with that bug fix. So that's been really handy on Beamlines, because it allows only those Beamlines that are sensitive to that change, that need that change, to be able to run it. And everybody else can continue running the older version until they also want to upgrade. So it gives sort of maximum flexibility. The Beamlines can upgrade when they're ready to, and we can install the software as soon as we have the fix, and that doesn't automatically make their stuff change, because users don't want changes coming from outside. They want to be in control of all of the software that's running on their Beamlines. They have to have that.